Okay, guys, we were just talking about this, permutations and combinations. Permutations is always more, or there are going to be more permutations than there are combinations, okay, because order matters. So let's look at the three letters A, B, C. This doesn't have to do anything to do with example number 1, but just to keep it clear in our head. If I'm looking at permutations where order matters, and I've got three letters, I can make ABC, ACB, BAC, BCA, CAB, or CBA. Okay, there are 6 different permutations for these three letters. But do you see that there's only one combination, ABC, in whatever order? There are more permutations where order matters than there are combinations. How many combinations of letters do I have in this group? How many combinations, Simon? Just one, right? Okay, so let's look at this first example, which is super easy. And it just says, a basketball league has 5 teams. Bless you.
Thank you.
2 of the teams can be chosen to play one another. List and count the different possible matchups. Now, guys, I'm not going to give them names because that'll just make it too long and too hard. We'll just call them A, B, C, D, and E. Here are the 5 teams that are playing. Now, it says this league wants to, it has 2 of the teams can be chosen to play one another. List and count the different possible matchups. So A could play B, or A could play C, or A could play D, or A could play E. Now, do I need to say B could play A? No, I've already said that. It doesn't matter what order they come in. Bless you. So it's B plays C, B could play D, B could play E. Okay. C could play D, C could play E, and then D could play E. That's it. 4 plus 3 is 7, plus 2 is 9, plus 1 is 10 possible matchups. Does that make sense? Right? I don't want to list over here B playing A, because that one's already done. They're already played each other. I could say that C plays A, but I don't want to do that because they've already played each other. Or that C plays B. I don't want to say that because they've already played each other. Right? That's if permutations, if order mattered. But in a game, it doesn't matter which one I list first. Right? These are just their pairings. So there are 10 possible matchups. Now, guys, I'm going to go ahead and show you. It's in the next one. But to find combinations, right, of N choose R, I find the permutations of N choose R, which we did last night, and I just divide it by R factorial. Ooh, not that hard. Let me show you this. In this one, it was 5 teams, right? And we are choosing, how many are we choosing?
2.
We're choosing 2, right? So that's going to be P of 5 choose 2 over 2 factorial. All right, well, let's see what we get. That's going to be 5 factorial over 5 minus 2 factorial. That's what P is, right? Okay, well, let's see what that gives us. That gives us 5 times 4 times 3 times 2 times 1, all over 3 times 2 times 1. So this cancels with that, and I get 5 times 4 on top. But remember, I now have to divide that by 2 factorial, 2 times 1. And I'm going to cancel the 2 with the 4, and that leaves me 2. What's 5 times 2? 10. How many different possible matchups were there? 10 possible matchups. Right? We listed them all in the first because it was easy. But this little formula right here will tell them to us. Will tell us how many combinations there are. We have to divide them because we're getting rid of the duplicates when we divide it by R factorial. All right, great job, guys. Let's look at the next one. The next one's going to give us another example like this.